What must be, I can't think, when was it, about a year ago? Yeah. Is it, maybe not quite a year ago. In the science strategy, there is a section that is entitled Science Visibility. And I'll read it. It says, increase understanding of the role of science within the organisation as an Environment Canterbury and cultivate science literacy. And that's what this science seminar series is part of trying to do. So it's about trying to show some of the science that's going on in the organisation across, so other people can see that, and for us all to get an understanding of that. And it's great to have Marion giving the first seminar. Brodie's going to introduce Marion in a minute. But this is a seminar series that we're running every 6 weeks. We'll have a seminar. The next one is on December the 10th. And Philippa H. Snurl from Groundwater section is going to be talking about some groundwater issues. Then we've got a bit of a break for Christmas, and the next one will be in February. But it's meant to be running every 6 weeks. We'll be having it here as a regular feature as part of increasing our science visibility. So that's all I wanted to say. Thanks for coming along. Look forward to coming to the next ones as well. I'll hand on to Brodie to introduce Marion.
I'll be even briefer. Thank you. Kia ora everybody. My name is Brodie Young. I'm the manager of the Environmental Science and Hazards team at ECAN. So with that, it's my great pleasure to introduce Dr. Marion Gadsby, who is going to talk today. She, as Tim said, Marion's first up for the science seminar series. A little bit about Marion. She has a pretty extensive background in this area. PhD in applied geology, and she has worked in consultancy as an engineering geologist and has worked as an academic, both doing research and lecturing at University of Auckland, and also has had another role in local government as a hazards manager, working more in a civil defence and emergency management type role. So that's the other things too, Marion, but I don't know. So I'll leave it at that, but essentially Marion is our hazards analyst, geological. It's the only one we've got in the whole organisation. And she's going to be talking today about the particular hazard that tsunamis represent for Kaikoura. So, okay, yours. Thank you.
Well, thank you for coming. Tēnā koutou katoa. Ka tangi te titi, ka tangi te kaka, ka tangi hoki ahawa. Tihei, Māori ora. Ka whai mata te tapuai o Tangaroa, Tangaroa ka haruru, ka tanga te titi, ka tanga te kaha, ka tanga hoki aho hua. Te hei, Māori ora. Right, tsunamis and Kaikoura and Taniwha. So, found a few pictures of Taniwha around the place, and for anybody who doesn't know, Taniwha are wee monsters or big monsters that live in water and get really peed off with people when they break tapu, and sometimes they eat people and stuff like that, but sometimes they're actually guardians of a particular stream. So, Kaikoura. Why Kaikoura? Well, for starters, I'm going to tell you what this means. Ka whai mata te tapuai o Tangaroa. Tangaroa, of course, is the god of the sea, and it means he strides back and forth o Tangaroa. Tangaroa ka haruru, hear him roar. That's quite an old whakatauki, and that's the literal meaning. The more contemporary meaning is that unwelcome events cause a big reaction. And that's one of the ways that Kaikoura is a little bit special. When we started talking to Kaikoura District Council about tsunamis and the hazard that they've got, It did not go down well. They didn't want to know. You'll scare off the tourists. We don't want to know. There's no particular hazard. There's no evidence. And that was what we had to deal with. Before I move on, I just want to point out these times. If I look at the waves in this, it's just made up of waves. It's a more contemporary one. Even in here, you see the waves. Right. You can't read that, but this is actually from the Civil Defence Group Plan, and this is the risk profile that we've put together. And all I want to say on here, so we've got consequences along the top, and we've got likelihood down the side, and all the risks and hazards that we've got in the region have been slotted in here. Now, we've not got any that come under this catastrophic and very almost certain category, these really significant ones. But in this orange zone here, we've got an alpine fault earthquake, we've got a regional tsunami, and we've got Kaikoura local tsunami. It warrants its own mention. Let's get the you want to see all the gory things, so let's get that bit out of the way for the start. What do tsunamis look like? Tsunamis, people think of a breaking wave, and they think of waves washing ashore and washing out. It's not quite how it is with tsunamis. Tsunami goes up like that, and then it stays up. They've got a very long wavelength, so rather than being a small block of water, it's actually a very big block of water. The wavelength is actually as important as the wave height in terms of what it does when it washes ashore. So instead of washing ashore and washing out, they actually wash ashore, but they can't wash out because they're still washing in. And that's why they go so far inland. So if you look at this scene here, that's what happens when the tsunami comes in. So if I just go back, that wall there, if you think about the height of the bus or whatever, might be 4 or 5 metres, and just in this area, the whole of the sea has risen by that amount. I don't get how those cars got there, though. I don't know. That's a bit of a mystery. Yeah. So that's more what tsunamis look like. And then, of course, that as the sea continues to rise, it just continues on over. Kaikoura. If you look at this is work done by GNS last year. They've remodelled for the whole coast the wave heights that we can expect around the coast, and they use big words like deaggregation plot and recurrence interval and percentile and stuff like that. But essentially, they reckon that every 2,500 years, Christchurch can expect this size wave, 12.7 metres. Kaikoura, 7.8 metres. This is only on the faults. But if you look at where they can come from, that wave height, the probability that is biggest that it's going to come from Peru for Christchurch, or Chile, or North Chile, or Japan. All distant sources, right? There's a wee slice for the Hikurangi, which is off the North Island. There's a wee slice for the Wairarapa Fault, which goes through Wellington, and then the others. 3/4 of the likelihood, it's most likely to come from overseas, which means you've got 13, 14, 15, 16 hours to sort it out, get everybody out. If you look at Kaikoura, it's unique in our region. Most of the districts have this sort of profile, very similar. Kaikoura has got, the biggest is from the Wairarapa Fault. We've got this much Peru. The Hikurangi, now for Kaikoura that actually counts as a local source. It only takes maybe half an hour, maybe an hour to get there. And then that one's actually a combination of 3 local faults, Hope Fault's another local fault, Kekarangu's another local fault. So all the sources for Kaikoura, almost all the sources are local. What difference does that make? Well, you don't get very long. You might get an hour. You might get 2 hours if you're lucky, but you're more likely to get half an hour or less. Okay, so that makes Kaikoura different. Responding to something like that is quite different from having 13 hours to evacuate everybody. When you look at how faults, how tsunamis form, if you think about subduction zones, we've got one here on the edge of New Zealand. We've got another one here on the other side of New Zealand. We tend to forget about that. We think about overseas and we think about our distant source, and we're looking over this way towards Chile and Peru. Australia, whoops, that wasn't good.
I just leaving it there, Marion.
Okay, well, while I'm waiting, what I was going to say was the way tsunamis form is by some disturbance on the sea floor. So we think about big subduction zones, and you've got one plate leaping under another. What happens is, as it goes down, the top plate, sometimes rather than sliding, just couples on, and it begins to distort as this goes down. And then all of a sudden, it'll let go, and it'll go bing, like that. And that is the earthquake, that's the source. It goes bing like that, and it's got this much water above, which goes like that, and then it goes, flows off in both directions. What I was saying before was that we tend to forget this one, but that's the one that Australia is looking at for its distant source tsunamis. Kaikoura, this one here, so these are very big, very deep, and they affect a lot of the cross. Kaikoura, you can see that what happens is the tsunami usually shoots off perpendicular, inland and out to sea. So if it happens up here, for us down here, not so bad. We might get some wash off the end of it, but if it happens down here, where this starts to curve around, that's actually starting to shoot down our coast more, as well as being closer. That's some modelling that we've actually got underway at the moment. We've not finished that modelling yet. But that will be of great interest to Kaikoura because it's so close. As well as that, so that's what we call the Hikurangi. That's that one slice of the pie that was the Hikurangi. Offshore off Kaikoura, you've also got all these larger faults here, and if you compare these to the ones down off Christchurch, these aren't capable of giving us very big earthquakes, so they're not capable of giving us very big tsunamis. These up here can do a magnitude 8, which is quite a significant tsunami, and very close to Kaikoura. So this is why Kaikoura has got a bigger, more significant local risk of tsunami than the rest of the region. And just as a point here, people think of a tsunami as a great big thing, but it's like the earthquakes. They're happening all the time, but you only feel some of them. Tsunamis, depends how big the earthquake that sets them off is, but most of them you wouldn't even notice. They're a millimetre by the time they get there. But these big ones happen much less often. So if you look at one of these offshore faults here, and I believe it's this one down through here, this is the Kekarangu Bank Fault. We did, back in 2004 to 2006, we did some modelling of that with NIWA. We commissioned some modelling of that. They set off the fault, chucked it into a computer program that worked out all the physics of how the waves travel, and then looked at what information they'd got about the shape of the sea floor, the bathymetry, and the topography, and this is what they got. So it washes up a little bit around the edge here, around through here. So if you felt the quake, you'd want to be out of it through here. Round in South Bay, not so much. If you look, so if you go down the coast and on down here, then you get to Goose Bay. Nothing much there. It's actually quite sheltered by the peninsula from this fault that goes up through here. Nothing too much there, but something. And we probably should rerun this now. There may be bigger faults, bigger earthquakes capable of happening on that fault, which could cause more inundation. But that one's not particularly bad. So far, all I've talked about is faults causing earthquakes. But there are other things that faults causing tsunamis, but there are other things that set tsunamis off as well. And yeah, indeed, we do sometimes get strange things falling out of the sky, hallelujah. We don't tend to model asteroids and things like that, but you can get things like volcanoes going off. under the water, setting off tsunamis. But more often than not, the other significant source is landslide. So if you get a big block of sediment setting off at the same time, then that can actually suck down the water and cause a tsunami on the surface. And these, they tend to be very localised, but you can get very, very big waves over a small area. So this is one where it was a 6.4 kilometre cubed of material went down the slope, which is a massive landslide. It was in 1,500 metres of water, and it caused 10 to 15 metre high wave. In Norway, there was one that was only 0.02 cubic kilometres, but it was in very shallow water, which makes it much more effective. It makes a much bigger wave, and that ran up to the 9 metre contour. And if you want to see a mechanism of how that works, so you get something setting off down, you get material setting off down the slope. It sort of sucks it down as you go. It goes, and then this bit of water doesn't like being higher than this bit, so it fills the gap. And that's where your tsunami goes, and these waves can be huge. Now, why is that relevant to Kaikoura? Well, this is the sea floor in Kaikoura. So the coastline is in green here. So here's Banks Peninsula around, and that's Kaikoura there. So you can see that if I put that on, that's a kilometre deep there, and that's 2 kilometres deep. So right on shore, you actually get very deep water, very close to shore. There's nowhere in the world where such a deep canyon comes so close to the coast. It's actually an excellent spot for researching all sorts of things. That's why the whales are there, because of all the creatures that live in there that bring the whales in close to the shore in the deep water. Now, the thought is, and this was some work that was done back in 1999 through to 2004, we know the sediment moves north. And they looked at the sediment budget, so this was Phil Barnes and co. Looked at the sediment budget, and they worked out that, yeah, it goes north, but there was a thought that some of it might be getting tracked right here onto the top of the canyon and building up into a huge pile of sediment that might set off. We didn't know whether it sort of disperses more or what, but they postulated that the main accumulation happens here over a sort of a 3 kilometre square block just here. And they estimated that a quarter of a cubic kilometre must have built up there, which means it must be 80 plus metres thick. Now, if that all sets off down the canyon, it's quite shallow here, and so that would make a big tsunami, and that would wash ashore quite quickly. So, is there a tsunami hazard here? This was the point at which the mayor got twitchy and sent us out and said, we're not going to accept this report and whatever. Anyway, we decided, okay, well that's fine. What happens? So that's just a word on landslide volumes. If you look at the Kaikoura Peninsula, if you said that was a third of a square kilometre, if you put a metre of sediment on top of that's a third of a cubic kilometre. So if you put 3 metres worth of sediment across the peninsula, that's the sort of volume you're looking at. If you look deep in the canyon, we've got some big bites out that are almost certainly old landslides that are sort of 12, 8, 2 cubic kilometres. They're massive. But those are quite deep in the canyon, so hopefully wouldn't, that sort of gets dissipated. It's not quite so bad by the time the landslide happens. So anyway, big block of sediment, what would that do? And we did this modelling here. And so this is similar to the other one, done at the same time, but this is the Kaikoura Canyon. Now this time, you've got South Bay. It's just right up to the cliffs. The whole of the settlements covered. Not much around the north side, but on the south side it happens here. So if this happens at night when everybody's at home, then you've got a disaster. If it happens when everybody's at work on the other side of the peninsula, it might not be quite so bad. If you look at Oaro, you've got trouble. There's nothing there. This is deeper than 2.5 metres right the way through Oaro, and the same for Goose Bay. Goose Bay, in this model, experiences a 12-metre wave a minute after the canyon sets off. Oaro gets 3 minutes and a wave about the same size, 7 minutes before it gets to gets up here. Now we think that it's going to take an earthquake to set off the canyon. We don't actually know. But if you feel the land, if you're in Kaikoura, if you're in the south, you feel a landslide, well, in the north too. If you feel the earth shaking, move to higher ground. So how real is it that all that sediment sits there? Well, we've started a 3-year program with NIWA to check that out. So there's a couple of things that we've done. We've done multi-beam looking at the bathymetry. Now what this is like a fish finder. And so a fish finder, the depth sounder that tells you how deep, like you send the beam down and it comes back up and it's receiving, it tells you how deep it is. Except this has got multi-beams, and so you actually end up with a 3-dimensional picture of the seafloor. And some of these landslides and things that we picked up earlier have been done using this sort of thing. The other thing we've done is actually look down into the sediment pile using boomer seismics. And the way this works is you tow lines off the back. You've got a seismic source here, and this is called a boomer seismic, but it goes pop, 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 pop. This is not like what Anadarko goes with, you know. And then we also tow a whole lot of receivers here, so that the beams go down and bounce off various layers in the sediment, and you can actually get a picture of what's happening in the sediment. And there was some concern expressed about whether the sea mammals would like this or not, but that's actually the sea mammals out there. They loved it. They were playing around the boat for most of the time we were doing this. So we went backwards and forwards across the canyon, and this is what we end up with. I've already shown you the bathymetry. This is the seismic, so you're looking down into the sediment pile. Now there's a big vertical exaggeration here, so that's why it looks so steep. It's probably more like 30 degrees. But there's, you can see that there's layering in the sediments. There's a couple of significant things here. This is the soft sediment here. This is the stuff that's starting to consolidate into rock. That's quite a significant erosion surface through there. So that's the soft sediment that's accumulated, and it's nothing like 80 metres thick. It might get close to 50 in places, but overall there just is not the volume of sediment there that we feared. Okay, so that modelling isn't quite fit for purpose. However, this slope down through here, this layer down through here, if you've got a nice slope that's heading towards open space, it can provide a nice surface that's very good for the sediments to slide off. So that's a bit of a concern, because what sediment we've got here could actually perhaps go all at the same time. So we need to know what effect that would have. It might not be as big, but we need to have a look at modelling that. So in order to model that, so the first thing is the main accumulation is not in the top of the Kaikoura Canyon. It's distributed, and so it's actually heading off. A lot of it actually gets channeled down this Haimuri Canyon down here, this small branch here, and then there's some distributed sediments through here. There is some sediment build up here, and there's some here that could cause landslides, so we're going to model those. And then there are also those deeper, big scarps that happened in the harder sediment, and we'll need to have a look at those. Although they're deeper, they're very big. So we went back this year, and using the seismic profiles that we got, we located decent places to actually do some more experimentation. And this is what we use. This is a free-fall cone penetrometer. Some of you might have seen cone penetrometers around Christchurch. It's basically a probe that you drop into the sediment, and it measures the tip resistance and the friction, and that will tell you something about the nature of the sediments, how hard they are, how sticky they are, what sort of grain size even. And that tells you something about how well that mass is going to hold together. So that's the first thing. And this is the thickness of the sediment part here, and that's the profile that we're doing here. This is where we dropped the penetrometer, and we particularly targeted that layer there because we want to know what's the nature of that layer. Is that a slider? We also took a whole lot of samples. So this is like dropping a drain pipe in, pull out the sediments, and then you take them back to the lab and you torture them until they give up their secrets, basically. So you squash them, and then you see how they deform, and again you can tell something about the sediments. When you've done that, don't worry about the pictures, you basically put the parameters that you've worked out about your sediments into a model, and you work out what stress it would take, given the slope and all that, to cause a landslide, what size the landslide would be, and what ground shaking it would take. We're looking at where the faults are and what the ground shaking is likely to be. And then when you've done all that, you work out what size and shape of landslide you're likely to get under the sea. So that's one lot of modelling. The next thing is you work out what tsunami that would form and end up with that. Now that's not been done yet. We're still part way through this process. We've got a PhD student on there, so we actually got over 100 cores, and so we can get a really decent handle on this. And so we decided to take a little bit longer over it. It's actually probably going to turn into a 4-year program now, while we get those numbers out. So modelling, 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 and more modelling. And yes, we'll have a look at the seafloor and see whether the model works, and then we'll do another model. So is there any other evidence, apart from modelling, that this could be an issue in Kaikoura? Well, there are historical accounts, and I've just put those up there. I don't expect you to be able to read them, but there's the sorts of things where there was a great big surge that suddenly came up over the lighthouse reef. There was a guy's boat who was that was carried 25 yards inland as a result of a tsunami. And then this one's particularly interesting. The story of a fisherman in his boat returning to Kaikoura and travelling in the area near the head of the canyon, and suddenly the sea was boiling all around him, and he nearly lost the boat. And then it all went calm again, with the waves generated rippling out to the shore. So that might have been a smaller scale sort of landslide happening off the edge of the canyon. The other thing that you can do is look at the soils on shore. If you get a tsunami washing ashore, you may well get either erosion or a build-up of sediment, or perhaps a bit of both. Now this one's Japan, and this is how much sediment in this location, the Tohoku deposit, left. And there's a nice sharp erosional base to that as well. If you dig down, you can actually find other tsunami deposits through here. And in Japan, they've got a much longer historical record, so they've actually got historical records that match the soils as well. They've got a beautiful ash layer there, which is a good time horizon. That volcano that kicked that off, we've also got historic records of that. And then down here they've got another one, and they've actually got historical records of that tsunami too. So that's the sort of sequence that you can see if these deposits form. And this is something that's not actually being done very much in New Zealand at all. There's been some, but not that much. If you can mix that with archaeology, then you might get some timelines happening in our context as well. This here, if you look here, you can see these big stones here. I've seen something very similar to this in one of the bays off at the end of Banks Peninsula, but this one's actually Northland. These stones are actually baked, so they're actually oven stones, so it's like a hangi. And then you get this layer coming through here, which is quite disrupted, and you've got a few of these oven stones are actually lifted up through it. And if you look at these deposits through here, there's actually salt water been through here, so you can do geochemistry on it. You can look at the fossils, and you can see deep sea fossils in some of this as well. This is probably a reworked midden in here too. And these layers, if you look in close, you can see these individual layers. They're probably the different waves coming in. A tsunami's not one wave, it's often a sequence of waves, and each will erode the one before. And so here, this is post Maori settlement. In Kaikoura, there are on Seddon, on the cliffs near Seddon, there's 150 to 200 years old. There was before that there was a Maori settlement there, and then there was abandonment, and there's a layer over the top which is a marine layer. Okay, further inland there's actually a 650-year-old settlement, and again it's very similar to this with reworked stones and a marine layer over the top of that. So this is managed retreat. And after that, no more. After the storm layer or the tsunami layer, there's no more settlement there. So this is a history building up from what we can see in the rocks and in the archaeology. If you've got the archaeology there, it gives you a timeline as well. And sometimes, as well as the archaeology, there might be a story that goes along with it in an oral tradition, and this is what we call pūrākau. These are the Maori oral histories. So this one over here, this is a modern depiction of a story that came up in Taranaki, and there was a group that went offshore. They got washed ashore by a storm and settled on an island, and they liked it there, so they stayed. But then, after a while, a Taniwha got irritated by them, and it wiped them out. Now, if you go to that island, D'Urville Island, there is evidence of a big tsunami back in the 1500s. The people who got washed off were of a particular generation. You can count back the number of generations, and if you say a generation is somewhere between, say, 14 and 40 years, you can actually get a date for that event. If you go and date the sediments there using radiocarbon dating, you've actually got about the same error bar, but you've got the same age range. So that's what they've got up in Taranaki. There are a couple of Taniwha stories local to Kaikoura. At Lyle Creek that runs through Kaikoura, there's a Taniwha that waits for people to cross the split between the sea and the lagoon at the stream mouth, and sometimes it eats people. Now, Taniwha aren't always tsunamis. Sometimes they're storms, sometimes they're associated with rivers. It might be flooding. That creek's renowned, often floods. But this one here might be a little bit more tsunami related, because this is two girls going between Omihi stream to Oaro River. And remember, Oaro is the one that gets washed out in the modelling. They were so engrossed in their task that they didn't notice that a Taniwha had risen up and completely surrounded them by water. At the last minute, one girl jumped to safety, but the other was eaten, and later her body was spat out and thrown back on the shore. So some of these stories, they may not of themselves tell us much, but it's just another line of evidence. When you're working with tsunamis, because we've got such a short history here, it's like working on a 1,000-piece jigsaw where you've lost 960 pieces. So you just got to pick the pieces where you can. But particularly if you do get a Taniwha story that lines up with the geology, you do have to be careful, because the written accounts aren't always the same as what the oral history is. So in some ways we actually need to go back and talk to any elders who still have these stories to get the context, to make sure we're not doing too much interpretation. But it's just another piece of the story. This here is a cave drawing from South Canterbury of the Taniwha. And it looks like he's just about to have a meal as well. So the conclusions that we've come to are tsunamis are real. They're a real hazard. in Kaikoura. We don't know exactly, we've not got detailed figures on the latest modelling, but we've got that. We're working on that. Distal sources don't seem to be such a problem for Kaikoura. They've got some. But the local tectonic sources, we really need to understand them better. We're working on the Hikurangi at the moment. Landslide sources could be a big one. So, where do we go from here? Well, where we're going is we're working on the landslides to work out where the landslides will be and how big and whether they need an earthquake to trigger them. That's important, because if they go off without an earthquake, how do you know? You just know because you wake up and you're in 3 meters of water. So that's a good to know. Modelling of tsunami scenarios from these landslides, that's going to happen in a couple of years. We're also, as I said, working on some of these tectonic ones. We might go on and do some paleo-tsunami research, see what else we can find there. There's not been much done, and if we can tie those in with local purakau, then that's going to add to the picture. I'm aware that I'm probably not going to be able to fit all this into my nice, neat little ECAN year once we start engaging with the local runanga. Things might take a bit longer, so I'm going to have to work out how all that goes. When it comes to what do we do with it, well, where we started off with the mayor actually just about kicking us out of well, literally kicking us out of the room, we've started talking to the community and they've started to engage with us. Back in March we had a series of 6 meetings with the public to look at getting the community ready for tsunami, and we had 150 people show up. There are 3,000 people who live in Kaikoura, so that's 5% of the population showed up. So that's actually quite a different, and they were fired up. They want to get community response plans going. They want to sort out where they can make evacuation routes, think about opening up routes so that they can get to higher ground if they feel ground shaking. Think about where they go and how long they stay and whether that's going to work. It's quite a different problem from where you're taking people away over a period of 13, 14, 15 hours. So what we tell them is if there's a large earthquake, go away from the coast and go up. Get a family emergency plan and practice it. So we're actually working on this kind of readiness with the community. So just to be clear, what are the signs? If you feel a large earthquake, which is one that's so big that you can't stand up in it, or one that goes on for more than a minute, or if you see the sea behaving in a strange way, suddenly coming in or going out or boiling, well, that's ka whai mata te tapuai o Tangaroa. He strides back and forth. Or if you hear strange noises coming from the sea, and this is literally true. Back in the 40s, there were tsunamis that were reported that sounded like express trains. The Japanese tsunami, there were reports that it sounded like a jet engine. So this is Tangaroa e Haruru. This is roaring. If you feel that, or hear that, or see that, that's a sign that could be something going on, and you just move to higher ground and inland quick. And you don't hesitate, because what have you got to lose? Just go to higher ground. And I'll finish with that, because it's my birthday in about 3 weeks, and I want that. So if you've got any questions. Yes?
What does that mean for some of the main highway routes and for people getting in and out, or people travelling along and they feel in that massive earthquake? It's pretty difficult to move to some of that higher ground without boats.
It is, and this is why we need to get the community right on side, because we need to be able to put in routes along State Highway 1, and some of that ground is quite steep and it's pretty rugged. And you know, we gave a community presentation in Goose Bay And there's a little old lady says, I've thought about this. She says, and there's 3 lots of barbed wire I've got to get over, and somebody's put glue in the lock on the gate, you know. So all of that you can do something about. You can open it up, put signage there, put signs along the road. That's what the mayor didn't want to happen because he thought it would scare off the tourists. But actually, what we were doing in March was saying we want to help you become a tsunami-ready community, not doom and gloom. Let's do what we can. So, yeah. But that highway is extremely vulnerable, and it's one of the reasons that this comes up as very high on our regional risk profile as well, because the rail goes there too. And if you there's so many trucks and so much fast-moving consumer goods come down that coast. If you cut that off, then it's a very long way around because the inland route's not really up to.
So what's our response as a civil defence unit?
Well, we're talking to Kiwi Rail and we're talking to NZTA, and they're involved in the Kaikoura Tsunami Liaison Group that we've got going, and we're talking to them about beefing it up. I want to see an alternate route inland. Trouble is the alternate route inland goes right along the Hope Fault. We've got everything in Kaikoura. Yeah.
If you travel on that state highway, how do you feel about that?
Well,
fine.
I don't. You could probably tell me more. Who was driving? Who was driving when the quakes happened here? That would be the sort of. It would be a similar sort of scale of shaking to what was happening here.
But if you think about putting some scale rails,
Yeah.
would you also think about putting some alarm system?
Tsunami sirens, they're very contentious actually, and one of the problems is that, for example, in Japan they had sirens and they practiced using sirens, and that was great because they all knew what the sirens meant. And then the earthquake happened and they buggered the sirens. The earthquake actually broke the sirens, and then the sirens didn't go off, so the people knew there wasn't a tsunami coming. So they didn't take the natural warning, which is the earthquake. That is the warning that you get. So you've got to be really careful around those. Tsunami sirens are also very, very expensive. And with 3,000 residents, Kaikoura district they've said it's not for us. We can't afford it. So.
Is there we have lots and lots of tourists coming into Kaikoura?
That's one of the things that the Kaikoura Tsunami Liaison Group is looking at. And one of the real problems is the campsites along the seafront there, and people like freedom campers who you might not even know are there as well. And that's why those signs are really important, and even signs on the toilet door at the campsites. You know, if you feel this is it, evacuation route here. And I mean, if we could put that alongside a history and whatever, it might, you know, so that the signs are multi-purpose and people will actually read it because they're interested in, you know, we're thinking about all sorts of things that you can do there, but also getting some of the YHA and some of the motels getting their own plans going, particular communities having responsibility for particular areas, that sort of thing. It's a big job, but it's really important. And then they're selling themselves as community, you know, a community that's ready for tsunami, which is a bit like when you get on the plane, the lady says, in the unlikely event of, and then she shows you where the escape routes are and all that. Nobody says, excuse me, can I get off? You know, everybody accepts that and you feel better and safer because you've got that plan in place.
Sorry, I'll just add on to that as well, just Andrew from the Civil Defence team. We've got a summer system we're looking at all that visitor action planning type stuff as well, and that's usually just 10 weeks time all that data together. But it's just not for Kaikoura, but a lot of our tourist hotspots, it's Hamner, Mount Cook, all that sort of stuff as well. So again, it's always lessons learned that they came across after the earthquake. Tourists will know documentation, that sort of stuff as well. And the other thing some of the communities done up at Kaikoura, sorry man, I think it was before you started here actually, they identified putting in like VHF radios into some communities, and we worked with a project with them to do that as well. So I think we got up with Clarence, Goose Bay as well, because we know they can lose their telecommunications. And we're doing a joint project with Kaikoura and Hurunui Council at the moment with a radio network that's going on the inland road. There's well, and that goes on next month. So again, we've got sort of more resiliency as far as telecommunications goes, with people contact with them. As we saw in Easter, we lost communications with them.
Just wondering, do you think there's any increased risk of vibration and stuff from deep sea oil drilling, or has it been kind of considered?
I don't think that would cause a big enough event to set this off. So there may be some, but I don't really know enough about that, but I don't imagine it would set anything big off.
The sediment sources that you were looking at coming from the south.
Yeah.
But, I mean, there are some, I mean, you've got the Clarence, obviously,
Yeah.
but some of those local rivers are coming off some pretty steep
Yeah, they
country and bringing a lot of sediment with them. Are they a significant source as well? Or?
I think that a lot of that is sort of gravelly, and I don't think it gets carried offshore
Okay.
so much.
Yeah.
And I mean, that calculation there only took into account the sand fraction that's travelling up the coast, because the gravel tends to stay put more, and the mud tends to get washed away way offshore. So it's the sand that's the fraction that's more problematic. But yeah, there's a hell of a lot of shingle coming down off those hills. That alluvial fan, don't like it.
Yeah.
So it's a different problem, different day.
If you get an earthquake and it's slip, and they get a landslide, and the earthquake causes tsunami, the landslide causes tsunami. It's going to be like a cumulative single tsunami, tsunami. And like, or you're just going to get two big ones, and the first one's going to do enough damage.
Well,
in the first place.
that's a really good question, because that's the question that people don't tend to think about. What happens if they both go together? It depends whether the landslide goes right away. If you think about it, the shaking might be over here, the landslide might be over here. You're going to get waves coming towards each other, and then what happens in the middle is you get a bigger sort of constructive thing, so you get bigger troughs, bigger waves right in that middle bit. And it just depends on the timing of it. If the shaking causes the landslide immediately, then you could get quite a big thing, but there might be a delay where it's not at the same time. So that's actually very difficult even for the modellers, but yeah, it's quite scary. And actually in Japan, when they so you can do this modelling and it washes ashore this much, right? When you get a real tsunami, you can see how far it goes. You can look at what earthquake caused that, and then you can check your model out. Does your model work? So it's like running it backwards. When they did that in Japan, for a lot of the areas, their models worked pretty damn well. But there was one place where it didn't. It went a lot further inland than they thought. And what they think is there was a big landslide on that section of the trench, as well as the ground shaking, and that's what's made the difference. It's a bit difficult to tell because they had things like partition slips, so some bits were slipping more than others. There wasn't just uniform slip across the fault as well. But they reckon that a landslide, a huge landslide, is what made the difference there. So yeah, it can add up and make it worse.
They're kind of international cooperation because it's changing as quickly as like with Japan.
Yeah, there's a lot of interest, particularly in the paleo tsunami stuff. There's a lot of things happening in Japan. In fact, we're here, it's a little difficult to get that cranking. In Japan, since the earthquake and tsunami, the government has said, you will tell us where all these tsunami deposits are in the next 3 years, please. And they've thrown money at it. But some of the experts, some in Australia, some in Hawaii, and they've got a consortium going around that. But yeah, all the tsunami communities linked in together. There's all these different things. There's the modellers, and then there's the paleo tsunami, and then there's the archaeologists, and you piece the pictures together. Yeah.
What else have we also learned from Japan about the nature of the structures that we build, and in terms of those that have
We're looking at that, particularly in terms of vertical evacuation, because that's always an option. Build something that is tall enough and will stand up. So there's actually GNS and McDem, the Ministry of Civil Defence and Emergency Management at the moment have got a report that they're looking at on exactly that, the vertical evacuation structures.
First of all, I just want to thank you, Marion, for an incredibly fascinating talk. It does just remind me of, I've got friends who used to have a batch on South Bay, right on the water, and I told them once about this risk, and you've just really reinforced that there is an enormous risk. It was funny actually because he said to me, he's a strong Christian, and he said, "Oh, I live by faith, not by fear," and that was his answer to it. But it's a real risk, and I think it's the work that you've been involved in is critical to the region, and I think it's great to hear it. And I think the great thing also is to get beyond that. You talked about the mayor saying, I just don't want to know, and to get beyond that is the really positive aspect. I think that's really good. So, just on behalf of everyone here, I just want to say thank you very much, and thanks to everyone for turning up as well. And thank you.